All right, we're doing Algebra 2, Final Review, Part 3. All right, starting off at number 1. Identify the vertex and the y-intercept of the graph of this function. All right, for the vertex, my vertex, to figure out what the x is, I got to do the axis of symmetry, which is x equals negative b over 2a. Okay, in this problem right here, x equals negative b over 2a, and my b is right here, 8. Okay, my a is right there, this 2, which gives me a negative 8 on top. 2 times 2 is 4 on the bottom, and if I divide those, I get negative 2, and that's the x value of my vertex. Okay, now, what's the y value of the vertex? Well, I take my negative 2 and I plug it in. So if I have a calculator here, okay. All right, so I'm gonna put negative 2 in for x here. So I got this 2 here, got that 2, and in parentheses, negative 2, close up the parentheses, and it's squared, plus 8, and then negative 2 again, and then minus 7. And I get negative 15, and so that's my vertex right there. Negative 2, negative 15. All right, now the y-intercept. All right, the y-intercept is when x is 0. The y-intercept, x is 0. The x-intercept, y is 0. All right, so if I put 0 in for x, I'll just do the same thing here. In fact, I'll just go up here and highlight that equation, and then I'll just change these negative 2's to 0. So let's delete that, put a 0 there. And I'll delete that, put a 0 there, and look at there, it comes out negative 7. All right, so negative 7, and there's my y-intercept. What that means is, here's the x-axis, here's the y-axis, and so at 0, negative 7, that's the point that it crosses the y-axis, which is called the y-intercept. Okay, number 2, same thing, identify the vertex and the y-intercept of this one. All right, this is what's called vertex form. We got this x plus or minus number in parentheses squared, and then plus or minus a number. So right here, the opposite of this, negative 3, is my x value. And then right there, negative 4 is my y value. That's my vertex. So that's a little easier than this problem. And then, of course, the y-intercept. The y-intercept is when x is 0. So I put 0 in for x here. So I just get my calculator here. Okay. So I'm going to right here, I'm typing the wrong thing. Parentheses, 0, plus 3 in parentheses, squared, and then minus 4. Okay. And there we go, 5. So 0, 5 is my y-intercept. Okay. And of course the vertex, that means at negative 3, negative 4, right here's the vertex of this parabola, and it does something like this. See, that's what the graph will look like. We'll get to that in just a little bit. Okay, number 3. Write the equation of the axis of symmetry. All right, we just did that a while ago. The axis of symmetry is x equals negative b over 2a. Okay, so in this problem, x equals negative b over 2a. If I look at the problem, right there's my b, negative 8. Right there's my b right there. So I put a negative 8 right here. There's my a right there too. This is the c right here, but we don't need the c. All right, so right here, 2 negatives makes a positive 8. Right here, 2 times 2 is 4. And now we divide those. 8 divided by 4 is 2. So x equals 2 is my axis of symmetry. And what that means is, 1, 2, right here is the axis of symmetry that this parabola is centered on, something like that. Oh, this may not be right necessarily, but that's what the concept is. Okay. Number 4, write the equation of the axis of symmetry here. All right. Well, if you find the vertex, it's the opposite of this, like we did just a minute ago in number 2. So it's going to be positive 5, and then right there, negative 3. This is my vertex. Okay, well, the vertex is on the axis of symmetry. So right here's my x value, 5. X equals 5. is my axis symmetry. Okay? The x value of the axis symmetry is the x value in the vertex, because the vertex is on the axis symmetry, kind of like what I showed you here. See, there's my vertex, and it's on the axis of symmetry. So, since my vertex is positive 5, negative 3, x equals 5 is my axis symmetry. All right, number 5. Use vertex form to write the equation of the parabola. Now, here's my vertex, and it's already labeled 2, 1. 2, 1, so it's going to be y equals, all right, it's going to be x minus 2 then, squared. X minus the x value 2. So x minus 2, and then plus 1. And that's it right there. Okay? Now, just for your benefit, if the vertex was negative 3, 7, then it's going to be x plus 3, and then plus 7. That's what it would be. So it's the opposite of this in here, and then that number there. All right, number 6. Use vertex form to write this equation of the parabola here. So again, there's my vertex right there, which is 1, 2, negative 2. Then 1, 2, 3, 4, 5, 6, 7, 8. There's my vertex right there. It says use vertex form to write the equation. So it's going to be y equals, and right here, negative 2, it's going to be x plus 2 squared, and then positive 8, so plus 8. And there's my answer right there. Okay. What about number 7? Match the equation to the correct graph. Here's my equation right there. So if you look right here, negative 2 would be my x value, and then positive 3 would be my y value. So negative 2, 3 is the vertex. So negative 2, 3 would be right here. This ain't right. Negative 2, 3 is right there. This one right here has negative 2, 3. But if you notice, see how there's no negative in front of this? That means it's going up. So this would have to be my answer, because see, this is going concave up. If there had a negative in front, that would make it go concave down, and it'd be this one. All right, so a negative in front makes it go down. No negative makes it go up. And that's what the answer is right here, A. Okay. Right here, we're going to solve this equation. All right, so we can use the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so there's the quadratic formula. So in this one now, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And then where the a, b, and c's are, you put these numbers in. So right there's my a, right there, 1. All right, a, if you notice, goes in these two spots. So 1 goes here and here. Here's my b right there, negative 3. And that goes in these two spots. So negative 3 here and negative 3 there. And then c is negative 40. And c just goes in this one last spot here, negative 40. Okay, I kind of didn't write it big enough here. Let's just do negative 40 like this, and there you go. Okay, now if you do that, there's 1, 2, 3 things to do at one time here. All right, so x equals, all right, so right here, 2 negatives makes a positive 3. Down here, 2 times 1 is 2. And right here in your radical, okay, I've got negative 3 squared minus 4 times 1 times negative 40. I type this in, which is 169 when I type it in. Don't type the radical, just type. Now I can do the square root of 169, which comes up to be 13. So right here, the square root of 169 is 13. And now I've got two answers. Oh, I've got 2 answers here. I got 3 plus 13, which is 16, divided by 2, which is 8. There's one answer. Then I got 3 minus 13, which is negative 10, and negative 10 divided by 2 is negative 5. And there's my 2 answers right there. Okay? So on this one here, I'll do the exact same thing. So let me write it out here. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay? What's my a? Right there, 2. And that goes in these two spots right there. So a goes here and here, 2. Right there's b, negative 14, and it goes in those two spots right there. So negative 14 here, negative 14 there. And then c's right here at the end, and c's is negative 24, so negative 24 there. Okay? And now to do that, there's 1, 2, 3 things to do at one time. All right, so x equals, right there, 2 negatives makes a positive 14. Down here, 2 times 2 is 4. And then here, you just type that in the calculator. Look here, when you type it in, we'll type it in for you on this one. Do not type the radical. Just type in parentheses, negative 3. Okay, it's squared. And then minus 4. And in parentheses, we got a 2 and a negative 24. So I got a 2 and a negative 24. All right, that comes up to be 201. Okay. In the radical. Which I think I made a mistake on this. This was supposed to be a plus right there. I made a mistake on typing this out. So that means that's a positive 24. So let me do this again here. Okay, that should be a positive 24. Let me delete it off. There you go. Well, no. Okay, we're bunching this one up. We're making a mistake on it, but anyway. So it's like the previous problem. I think on the test, this is going to be a perfect number, so it's going to end up like 14 plus or minus 6 or something. I don't know. We made a mistake on the problem, so I'm sorry about the problem. But anyway, suppose it come up to be that instead of this, it'd be 6. Suppose that was a 36, square root of 36, which is 6. So 14 plus 6 is 20. 20 divided by 4 is 5. And then 14 minus 6 is 8, and 8 divided by 4 would be 2. And so there would be my 2 answers right there. I'm sorry I messed up that problem when I typed it out. I don't know what I did. Made a typo or something. Okay, simplify this expression. We're subtracting these. All right, the best thing to do, and I've told you about this, since I'm minusing this, we don't want to subtract. Instead, I want to distribute that minus into this expression here, which is going to make me have a negative 2x squared, a plus 7x, and a plus 8 instead of that. See, it changes them all to opposites. And now, I'll just add these two. So I go 5x squared plus negative 2x squared. 5 plus negative 2 would be 3x squareds. Negative 3x plus positive 7x. Negative 3 plus 7 would be a positive 4x. And then 6 plus 8 would be 14. And here's what I would have on that. Okay, so that's the way to do. When you have a minus in front of this, distribute the minus through and change them all, and then just add them. That's the best way to go. Okay, now, going to the next problem here. Okay, simplify this expression. We're multiplying these. So the thing to do is build a box underneath this expression here. We got a column for each one of these. And we'll take this 3x plus 4, and we'll make rows for it. And so we're going to multiply. There's 6 products here. So right in this first one, it's going to be 2x squared times 3x right here. So 2 times 3 would be 6. And it's x squared times x to the 1, which is x to the 3. You just add the exponents up. Right here, 8x times 3x. Well, 8 times 3 is 24. I got an x here and I got an x there. That's x squared. Right here, negative 7 times 3x is negative 21x. Right here, 4 times 2x squared would be 8x squared. 4 times 8x would be 32x. And then 4 times negative 7 is negative 28. There's all my products. Now what I do is I add the ones that are like terms. So like right here, these two are like terms. And those two right there are like terms because they're both x terms. Those are x squared terms. So I got a 6x to the third. 24 plus 8 is 30, so it's a 32x squared. Negative 21 plus 32 would be, what is it, 11, positive 11x. And then I got minus 28. And that's my answer there. Okay. All right, so I feel you can do that one. All right, now let's go to the next problem, number 12. Classify this by degree and the number of terms. All right, so by degree, okay? If you have just an x with no degree on it, that's linear. If you have x squared, that's quadratic. If you have x to the third, that's cubic. X to the fourth is quartic. And then x to the 5 is quintic. Okay? Now the number of terms, if you have one term, that's a monomial. If you have two terms, it's a binomial. If you have three terms, it's a trinomial. Oop. And if it has more than those, you just, like if it has four or more, then it's just 4 terms, is what we say. We don't have a word for it. Okay? So if you look at this, classify it by degree and number of terms. Okay, 1, 2, 3 has 3 terms, so that's a trinomial. Now you look at your highest degree, which is this one here. See, 4 is higher than 3 and 2, so this is the highest degree. It's to the 4th, which is quartic. So this is a quartic trinomial. Quartic because it's to the 4th degree, and trinomial because it has 3 terms. All right. Number 13, use synthetic division to perform the division here. All right, so look at here. This is 3, 2, this is 1, and that's 0. We're not skipping any terms. So I write those out. That's 2, 1, 5, and -6. And here, the 0 of this is 3. 3 minus 3 is 0. I got to put the 0 in this. Okay. All right, now when you do this, this is how you set it up. The 2 comes straight down. Now once I get them here, I times it by 3. So 3 times 2 would be 6. And then once I get them here, I add those. 7. Once I get them here, I multiply by 3. So 3 times 7 is 21. Those are 3. I add again. 26. 3 times 26 is 78. I add these, which is 72. Okay. So this is going to be 1 degree less. It was x to the 3rd. So this is going to be 2x squared plus 7x plus 26. And then this is my remainder here. So plus 72 over my divisor, which is x minus 3. And there's my answer right there. Okay. 14, which of the following describes the end behavior of this function? All right, so the end behavior, you look at your lead term with the highest power, which is this one right here. Okay, it's positive. It's a positive 3x to the 4th, which means on the right side, it's going up. Okay. Now, it's the 4th degree, which is even. So if it's even, they both do the same thing, which means they're both going up. Okay? Which means this. As x goes this way to negative infinity, it's going up to positive infinity. So that would be this right here. As x goes to negative infinity, as x goes this way to negative infinity, the function is going up to positive infinity. On this side, as x goes to positive infinity, this is going up to infinity. So that's, these two are both be our answers. As x goes to positive infinity this way, the function is going to infinity. And as x goes to negative infinity that way, the function is going to positive infinity. So that's how you do those. There's another one like that, I think, in just a little bit. 15. The graph of a polynomial function has zeros at 3, multiplicity of 2, and -2, multiplicity of 1. Write the function in standard form that could represent this function. All right, so if there's a 0 at 3, that means my factor is x minus 3. All right, it has multiplicity 2, which means it's squared. All right, then it has a 0 at -2, multiplicity of 1, which means it's going to be x plus 2. Okay, now all I do is I multiply these together. All right, so this being squared means I'm going to have x minus 3 times x minus 3, which that's that squared, times x plus 2. And I multiply all these together. And when you multiply, you only can do 2 at a time. So let's do these 2 first. So let's make a box down here. And I'll put x minus 3 on the side here, and we'll multiply these 2 first. So that's going to be x squared, -3x, -3x, and -3 times -3 is a 9. Okay, which these 2 go together. So it's going to be x squared minus 6x plus 9. So this is what I get when I multiply those 2. Okay. So when I multiply these 2, I get this. Well, now I got to take this down, and now multiply that answer to this. Okay? Let me pause for a minute. When you multiply, see, like if I have 3 times 5 times 4, multiplying 3 things, you can't multiply all 3 at once. You only can do 2 at a time. So like right here, 3 times 5 is 15, so there's my answer there. And I take it times 4, which is 60, and there's my answer here. That's what I'm doing here. I got to multiply these 2 first, get that answer, and then multiply it to the third one. Well, I'm going to build a box here like I did just previously. Okay, I got a column for each one of those, and I'm going to put x plus 2 over here to the side. Which means right here, x to the third, negative 6x squared, 9x, 2x squared, negative 12x, 18. Okay, oh, you get it on there a little better. So there's what I get when I multiply those. And now here's like terms here, and here's like terms. So I've got x to the third, negative 6 plus 2 is negative 4x squared, 9 plus negative 12 is negative 3x, and then I got plus 18. And there's my answer when I multiply those. Okay. Number 16, find the factors of this polynomial. All right, the factors are where the zeros are. So here's one here that looks like negative 6. There's one right there at negative 1. There's one right here at 3. And there's one right there at 5. Here's my zeros. These are my zeros, which gives me these factors. So right here, if this is negative 6, it's going to be x plus 6. Right here, since it's negative 1, x plus 1. Right here, that's a 3, it's going to be x minus 3. That's a 5, it's going to be x minus 5. And there's my factors right there. Okay, here's one kind of similar. Here's my zeros for this one. What's the polynomial in factored form? All right, if that's a factor right there, it's going to be, if that's a 0 right there, these are my zeros, it's going to be x plus 3. There's my factor for it. If x equals 0 is a 0, then it's just going to be x. I'll put it out front. Right here, because it's x plus 0, which is just x. Right here, this is x minus 2. And right here, this is going to be x minus 3. And there you go, there it is, factored form. Okay, which this one's similar right here. Number 18, here's my zeros. So that means right here, x minus 3, x equals negative 3. This is going to be x plus 3. Here, x equals 1, that means x minus 1. Right there, x equals 4, it's x minus 4. Here's my factors. And now, to get the polynomial in standard form, I multiply these factors. So let's build a box here. It's just like we did a while ago. We got 3 things. We only can do these first 2 first. We have to wait on this guy. So I'm going to put this guy to the side here. This is x squared, negative x, 3x, negative 3. So that's going to be x squared, those 2 go together, plus 2x minus 3. And here's my answer for these first 2. Now I bring this guy down and multiply it again. All right, so I'm going to build a box underneath this guy. Put an x minus 4 over here. This is going to be x to the third, 2x squared minus 3x, negative 4x squared, negative 8x. And we're kind of fast here. You can pause this and look at it if you need to. But now these are like terms here, and those 2 are like terms. That's usually how they go. They're diagonally like that. So this is going to be x squared. I'm sorry, x to the third. Right here, 2 plus negative 4 is negative 2x squared. Negative 3 plus negative 8 is negative 11x. And then I got a plus 12. There's my answer right there. Okay. All right. Let's go to the next one here. All right. Oh, this is easy here. We did this in behavior thing a while ago. All right. So you look at your lead term, which is this right here. That's the highest power. See how it's positive? That means the right side is up. The right side, if it's positive, goes up. If it's negative, it goes down. Okay? If it's positive, it goes up. If it's negative, it goes down. But it's positive, so it goes up. Now, the left side depends on the power. See how it's odd? And if it's an odd power, these 2 do different things. So that's going to have to go down, which looks like this one. Here's my answer. Okay. Number 20, here's another one. Find the end behavior for it. Well, the lead term is this one. Okay, so you got left and a right. Well, see how it's negative? That means the right one's down. The right one is whatever the sign is. If it's negative, it's down. If it's positive, it's up. Now, look at the power. It's 4. Which means it's even, which means they both do the same thing. They're both down, and so there's my answer right there, B. Okay. 21 here. Graph this polynomial. All right, so look here. Here's my factors. Well, look here. That's 2 times x, which that means x equals 0 is my 0. Right here, x plus 2 means x equals negative 2 is my 0. Right here, x equals positive 1. There's my 3 zeros right there. Okay? So I've got to look and see which one has those 3 zeros. All right, so it looks like right here, negative 2, 0, positive 1 right there. All right, but it also could be this one, negative 2, 0, positive 1 right there. So it's got to be one of these two. It's not this one. It's not that one. It's got to be B or D. Okay, now how do you tell? Well, you got to look at your lead coefficient, lead term. And this is factored, which means you're going to have to multiply the lead terms of each factor. So here's the lead term of that one. Here's the lead term of that one. Here's the lead term of that one. So I multiply these together, which is 2x to the 3rd power. And this is my lead term. It's positive, so the right side is up. And since it's the odd power, the left side goes down, and it looks like this right here. See how the right side is up and the left side's down? This is backwards. The right side's down and the left side's up. It's got to be like this, so it's got to be D. All right, about to finish up here. 22. Graph the polynomial function here. Also, just like we did right here, this is x equals 0. This is x equals 2. This is x equals 1. Okay, these are my zeros from those 3 factors. Here, negative 3 times 0 is 0. All right, so it looks like 0, 2, and 1. Could be this one. It could be 0, 2, and 1. This is negative 2. Those two aren't it. It's got to be one of these two. All right, well, you got to look at your end behavior. So you got to do your lead term. Well, this is factored, which means you take the lead terms of each factor. So this one's negative 3x. This one is x. And this one is x. That's the lead terms from each factor. So I multiply those, which is negative 3x to the 3rd power. Now, what's my end behavior going to be there? Well, it's negative, so the right side's down. And it's an odd power, which means they do opposite, so the right side would be up. I mean, the left side would be up, which is what's going on right here. So this is my answer. See, this is opposite. This is going down on the left, and it's going up on the right. That's wrong. The answer is this one. Okay. Number 23, factor this completely. All right, these are perfect squares. The square root of 9 is 3. The square root of 16 is 4. All right, so this is a difference of squares. This is 3x squared. And this right here is 4 squared. This is a difference of squares. So that means it's going to be 3x minus 4, 3x plus 4. There's my factors. Okay, 24. Determine the number of turning points. All right, this is easy. See how this thing's going through here? And all of a sudden it turns. Right there's a turning point right there. There's one. There's one. There's 3. 3 turning points. That's pretty simple. Okay, and now the last problem. Factor this completely. Okay, since this is to the 3rd power, all right, we're going to take our 64 and we're going to do the 3rd root of it. All right, so get the calculator here. Okay, and I want to do the 3rd root of 64. So where's my button at? I thought it was right here. Okay, you have to hit math. I think it's in here. Here it is right there. See it? The 3rd root of 64. It should be 4. Yes, it is. 4. All right, so that means 4 is a 0. Okay, so what I'm going to do is I'm going to do the synthetic division. This is 1c to the 3rd. There's no c squared. There's no c term. And then we have a minus 64. Okay. This 1 comes straight down. 4 times 1 is 4. And I add those, which is 4. Now I do 4 times 4 again, which is 16. And I add those, which is 16. Now I do 4 times 16, which is 64, and I add those, which is 0. So it divides perfectly. And so here's what we have. This is 1 degree less. Since that's x to the 3rd, this is going to be c to the 3rd. So it's going to be 1 degree less, plus 4c plus 16. Then right here, since that's 4, that's my 0. My factor is x minus 4. Oh, sorry, c minus 4. There's my answer right there. Okay. All right, so that's my final review, part 3. If you have any questions or need any help, just let me know, okay? Thanks for watching. Bye-bye.